Okay, number 1, remember that if these two lines are parallel, then we think of them as a fraction bar because they divide the triangle into proportional parts. So we can say that 5 over 5 equals 7 over x. Cross multiplying, we get 5x equals 7 times 5, which is 35. Divided by 5, we get x equals 7. And if you notice, how can we get 5 over 5, or 1, to equal 7 over something? That will also equal 1. And the only number over 7, or under 7, that'll equal 1 would be if it were 7 over 7. So that's how those two ratios will equal. Number 2 is the same concept. You have parallel lines dividing two triangles, and they're going to cut the two triangles into proportional parts. So we think of the middle line as a segment, or as a fraction bar. Basically, it's set up for us. We just have to stick an equal sign in between them and solve for x. So we can say that 20 over x equals 18 over 9. 9 times 20 is 180. Just cross multiplying here. And that's going to equal 18 times x. Dividing both sides by 18, I get x equals 10. Number 3 is a little bit different. Yes, these are parallel lines, but these are not the sides of the triangle. It's not dividing the sides into proportional parts. When you have the two bases of the triangles, where this side is the midpoint of this side, and this is the midpoint of this side, this is called a midsegment. And if you remember, a midsegment is half, so this midsegment x is half of the longer segment, 35. And half of 35 is the same thing as taking 35 dividing by 2. So 17.5. The other way you can do it, if you don't like dealing with fractions, is you can say that since this is half of the base, you can say that two midsegments, two x's, make up the base, 35. So then you're just left to divide by 2 on both sides, which is exactly what we did here, and you get x is 17.5 either way. So as you're doing number 4, you can do it two different ways. You can say that the midsegment is equivalent to, it's equivalent to half of 5x plus 30, or you can say that the base is equal to 2 of the midsegments. Okay, number 1 on the back, we're asked to find x and y, and you have 1, 2, 3 parallel lines, and as I said before, think of the middle line, think of the middle line as one big fraction bar. So they already set it up for you. You just have to stick an equal sign in between the two fractions. So we can say 5x over, here's my fraction bar, 36, equals x plus 12 over 12. Cross multiplying, we get 5x times 12, which is 60x. That equals, remember we have to put this in parentheses, it equals 36 times the quantity x plus 12. 60x equals 36 times x, which is 36x, plus 36 times 12. And 36 times 12 is 432. So I'm going to subtract 36x from both sides of my equation, and I get 24x equals 432. Dividing both sides by 24, I get x equals 18. In number 5, we're doing the same exact thing. We have 1, 2, 3 parallel lines. As I said, treat the middle parallel line as your big fraction bar. Just have to set an equal sign in between the two fractions or the two ratios. So we can say that 3 over x, there's our fraction bar, equals 4 over x plus 4. And we're left to cross multiply again. We have 4 times x equals 3 times the quantity, don't forget your parentheses, 3 times the quantity x plus 4. And that reminds us to distribute. So we have 4x equals 3 times x plus 3 times 4, which is 12. Subtracting 3x from both sides of my equation, I get x equals 12.